Today we're looking at section 3.1, solving equations using addition and subtraction. We're solving linear equations using addition and subtraction, and we're modeling them with real life problems, beginning on page 132 in Algebra 1 textbook. We have a few definitions. The first one is equivalent equations. They have the same solution as the original equation. So equivalent equations, and we'll look at some that have the same solution as the original equations. But think of that term equivalent, that means equal equations because they have the same solution, equal equations. Inverse operations are things that undo each other. Undo. So the inverse of addition is subtraction, and the inverse of subtraction is addition. The inverse of division is multiplication, and the inverse of multiplication is division. Those two things undo each other. A solution step is the result of applying a transformation to an equation when solving the equation. When we work problems, each step we take is considered a solution step. If you transform it or if you change it from what it says to something else based on a property that you learned, or by any other means, because you're simplifying or combining things, that is considered a solution step. So if we had 2 plus 3, for instance, and you change that to 5, that doesn't say the same thing. 2 plus 3 doesn't say the same thing as 5, but you combine those two things. This is a solution step to 2 plus 3. A linear equation, it's raised to the first power. Everything we'll deal with, for the majority of this course, we'll deal with linear equations, where y equals mx plus b. We'll get to this eventually, but x is raised to the first power. There's no squared. It ceases being a linear equation and turns into a quadratic equation when y equals anything times x squared. When it becomes a square there, it's no longer a linear equation. It won't be a straight line. But linear equation just means a straight line raised to the first power. Here are transformations that produce equivalent equations. First one says add the same number to each side. So you have x minus 3 equals 5. If you add 3 to each side, it gives you x equals 8. Most people, when they solve equations like this, they say, okay, we want to get x by itself. We don't want to have x subtracting something like we have in this case. So in order to undo subtract by 3, we add by 3. If you do that on the left side, you have to balance it out and add it to the right side. So you do the exact same thing on both the left and the right. And when you do that, you get x equals 8. The next one says subtract the same number from each side. X plus 6 equals 10. Undo plus 6 by subtracting it, and do the same thing to the right side to balance it. And 10 minus 6 gives you x equals 4. Then it says simplify one or both sides. Notice the difference between the first two examples and this third one. X had something subtracting from it and adding to it in the first two examples, but that x is all by itself on the left side of the equal sign in this third one. It doesn't have anything adding or subtracting to it. So just simplify the other side of the equal sign. 8 minus 3, and we know 8 minus 3 is x equals 5. And then interchanging both sides, 7 equals x means the exact same thing as x equals 7. This is just taking them and changing sides with them, putting the variable first. Example number 1 is adding to each side. X minus 9 is equal to negative 20. On the left side, 9 is subtracted from x. You can see x is not alone. It has something that says minus 9 with it. To isolate x, or to get x all alone, you need to undo subtraction. We know how to undo subtraction. We undo it by adding. So it says to minus 9, you undo minus 9 by adding 9. If you add 9 to the left side of the equation, you do likewise to the right side. You have negative 20 minus 9 on each side. and you add 9 to each side, negative 20 plus 9, it cancels it out on the left side and leaves you with just x. And negative 20 plus 9, opposite signs, one positive, one negative. Subtract the absolute values, 20 minus 9, you get 11. And since 20 is the higher absolute value, or it's farther away from 0, it's negative. 11 remains negative. So x's value is negative 11. You can check your solution by substituting the solution of x into the original equation. So take the original equation, x minus 9 equals negative 20, and plug in or substitute negative 11's value in x's place. So negative 11 minus 9 equals negative 20. And check its truth value at that point. Negative 11 minus 9, when you put them together, gives you negative 20. That is, in fact, equal to negative 20. You have a true statement. That's checking to see if negative 11 is correct. Example 2 is simplifying first. N minus a negative 8 is equal to negative 2. In order to undo minus a negative, anytime you're subtracting, you add the opposite. Minus a negative means plus a positive or plus a positive. So you're left with n plus 8 is equal to negative 2. In order to undo plus 8, you subtract 8 on both sides. Subtract it on the left to cancel it out. But if you subtract something from the left side, it makes it lighter on the left side. You have to balance it out by taking the exact same thing away or doing the exact same operation to the right side. So it'll cancel it out on the left and leave you with just m. That's what you were looking for. Equals negative 2 minus 8. Same signs, both of them negative. Add them up. 2 plus 8, you get 10. Keep that common sign negative to leave you with negative 10. N is equal to negative 10. Then you have some checkpoint problems. It says x minus 7 equals negative 15. Undo minus 7. Since we want, ultimately in this problem, we want it to say x equals all by itself. We don't have that right now. We have x minus 7. Undo that by adding 7. If you add 7 to the left, do likewise on the right. It'll cancel it for you on the left, and it'll leave you with x all by itself on the left. Negative 15 plus 7, opposite signs, so subtract them. 15 minus 7 gives you the number 8. And since 15 is the higher value or the higher absolute value, it's negative. It's farther from 0. It's negative. 8 remains as a negative value. X is equal to negative 8. And when we justify this step to get to show a solution step, say why we did it, the reason we added 7 is because it is the inverse of subtraction. We know the inverse of subtraction is to add 7. For number 2, you have to simplify before you use the inverse of anything. It says n minus a negative 6. Remember, anytime you're subtracting, you're supposed to add the opposite. Minus a negative means plus a positive. That leaves you with n plus 6 is equal to 4. And all we did for that step was to subtract. We added the opposite. Then to go from n plus 6 equals 4 to the next step, undo plus 6. We have n plus 6 equals 4. Undo plus 6 by subtracting 6. That's how you undo it. If you subtract 6 on the left side, do likewise on the right side. It'll cancel out for you on the left and leave you with just n. That's what you were looking for. 4 minus 6, opposite sign. Subtract 6 minus 4 and you get the number 2. And 6 is farther away from 0. Its value is negative, so n remains as negative 2. And the reasoning behind that one is that one was the inverse of addition. And then the only difference between number 3 compared to 1 and 2 is your variable's not on the left side. It's okay, because remember, negative 2 equals n, if you're just looking back at number 2, is the exact same thing. Negative 2 equals n is the exact same thing as n equals -2. So what we have is -7 equals 10 plus y. We still want to get y all by itself at the end. We don't want to have anything adding to y like we have 10 right here. At the end, we still want it to say y equals all by itself. So we have a positive 10, and this is where it gets a little bit tricky because there's no sign in front of that 10. Positive 10. We know that they're adding or subtracting to each other because of this plus sign. But that plus sign doesn't tell you what to do to undo it. You just know that that means they're combining with each other. This plus sign, the one or the positive that's not shown, tells you what to do. That says plus 10. Undo plus 10 by subtracting it. If you subtract 10 on the right, do likewise on the left. Subtract 10. It'll cancel for you on the right and leave you with y all by itself. That's what you were looking for on the right. -7 minus 10, both of them have a negative in front, so add them up. 7 plus 10, and you get you get 17, and keep that common sign negative. So y's value, or -17, equals y. All we did right there was we did the inverse, and it was positive 10, so the inverse of addition. And then if you need to make it look a little bit neater to yourself, you could change the order around and say y equals -17. And in fact, when you're reading the solution out loud, it always helps you to say the variable first. In this case, y equals -17. And if you look back to our transformations box, it says interchanging the sides. If you need to write that word interchange in to say 7 equals x is the same thing as x equals 7, or in this case, -17 equals y is the same thing as y equals -17. You can write in the word interchange. For number 4, you have 5 minus a negative x is equal to 21. So undo, or those aren't absolute value signs in the middle. That's just separating the problems. Undo minus a negative z. I think I read it as x a second ago. But minus a negative means plus a positive. Add them up. That gives you 5 plus z. See, notice we changed it, equals to 21. Anytime you change something, it's a solution step. So since we created a solution step, we're going to say we add the opposite to justify it. Then we, at the end, ultimately, we're trying to get z equals all by itself. We don't have that right now. We have something adding or subtracting to z because it says 5 plus z. But again, the plus between the 5 and the z doesn't tell you what you have to undo. The sign in front of the 5 does. It's a positive, even though it's not shown. It's a positive 5. We know to undo positive or plus 5 by subtracting 5. If you subtract 5 on the left side, you have to do likewise on the right side. It'll cancel out the left side for you and leave you with just z, which is what we were looking for. And 21 minus 5, opposite sign, so subtract them. 21 minus 5 leaves you with 16. And 21 is a positive. There's no plus shown, but it's positive. So z remains as a positive 16. And that solution step right there is the inverse operation, inverse of addition. Because 5 was positive. So the inverse of addition says to subtract 5 on both sides. You have to do something similar to number 5. It says m minus the absolute value of -3 is equal to 14. Absolute value acts just like grouping symbols, so you have to simplify what's inside of it first. So the absolute value means how far away from it is it from 0. -3 is 3 away from 0, so just bringing it straight down. Bring everything else down to go with it. M, bring down minus, there's the 3, is equal to 14. That solution step is the absolute value. It's the definition of absolute value. Then we want to undo minus 3. In order to undo minus 3, you add 3 to the left. If you add 3 to the left, do likewise on the right. It'll cancel you out on the left-hand side and leave you with just m equals 14 plus 3 is the number 17. That solution step is the inverse of, it said minus 3, so we added it, so it's the inverse of subtraction. Then number 6 says negative 8 equals negative b plus negative 2. Plus a negative 2. This is the same thing as negative 8 equals negative b minus 2. And just to keep us from, and remember this is a b, not a 6, just to keep us from having to do multiplication today, we're going to do this in this fashion, everybody. This is just subtracting to go from plus a negative value. We're just subtracting there. Just subtracting. So undo minus b by adding b. And again, this is a step that we'll be able to consolidate this step once we do multiplication on Wednesday. But add b. If you add b to the right side, add b to the left side. Now you cannot add b to negative 8. That's why I didn't write it underneath it, because those are considered not like terms. So what you have now is a positive b minus 8 equals a negative 2, because it'll cancel the b out on the right side. All we did for that step was we did the inverse, and it was minus b or negative b, so the inverse of subtraction. And again, that's a step that we will be able to consolidate. You'll understand exactly what I mean when we get to that on Wednesday. But it says b minus 8 now. At the end, we're looking to get b all by itself. We don't have that yet. We have minus 8. So undo minus 8 by adding it on the left. Do likewise to balance it on the right. It will cancel it here for you on the left and leave you with b on the left all by itself. That's what we were looking for. Negative 8, negative 2 plus 8, opposite sign. Subtract the absolute values, 8 minus 2, and you get the number 6. And 8 is farther away from 0. Its sign is plus, so 6 is going to remain as a positive 6. And all that was the inverse, again, just like the last step, inverse of subtraction.